Hello everyone, this is our third tutorial about creating our RevoEngine in C++ using SDL, Glue and openGL. And I was trying to draw a triangle, and this is for a further lecture, but we are drawing a triangle in here. In openGL you need to make the description of the points in counterclockwise, so this need to be in this way to get it work. And we set a lot of things in a wrong way because it's not object oriented, and we try to explain a little bit of it right now, but because it's more like a tutorial. And here we have a 30 described triangle. We need 3 coordinates. We need the x, let me write here, x, y, and z. This is our description of the points, and we have a point. Let me go again. We have a point right here, right here, and right here, and right here. This is the triangle description. It needs to be in this form. We're using VBO. This is a pointer to a location of the memory on the memory of the GPU. So we need to make this triangle in memory, right here, like this. We need to describe it counterclockwise, and we need to describe the points that make the drawn triangle correctly. We want to first came to the 0 that is in this position, this position. Then we need the 1, that is in this position, and we need the 2 that is on this position. So because the window is normalized, when we refer to 1, -1, and 0, we are describing this 3 points of the window, like this. The middle is 0, 0, and here is -1, -1, and here is 1 and 1. This describes a normalized window. And why we are using elements? Because if you want to draw a simple triangle, it's not a cost. But if you want to reuse the same point on a mesh, on a high poly mesh, we need to avoid using multiple triangles and points and thinking of a million of points, maybe saving some space in memory without duplicating the memory of without duplicating in points. It's better because we just need to describe the points that linked together can describe the surface. So this is why we are using the elements array and the triangle array. Here is some configurations about the openGL. We are trying to enable things like clear color. That is the color that will be drawn in the top of the back frame that will be swapped to the first, and then when we call GL clear, we want to clear the depth test buffer that we are enabling here and the color bit buffer. This is a OR bitwise operator because we want to concatenate these two operations together. And we draw a green back, totally green. This is a normal green, and then we start drawing things. And here we are going to describe these steps. Here we are giving its own description on next tutorial series, on next tutorial videos. Not right now. We're not going to show and describe this fragment at all in this video. And the call phase is we're going to leave this to the next video about shaders. And for our first triangle, we need to make a pointer that is called a buffer, VBO, because it's a vertex buffer object that is a pointer to a location on GPU memories, on GPU memory thing itself, and we generate. Then we, as openGL is a state machine, we need to make the operations and actually know where the pipeline is, know the pipeline states to make the operation flows through that pipeline. And here, when we generate, we bind this buffer, and now every operation going to be based on this memory location. And before any draw, we need to upload the triangle data to the GPU. So in this function, we describe what is the type, the size of the data itself, and how it's going to be drawn. So it's statically drawn, and we are going to describe this this parameter in future, near future on this tutorial, in the series, because it's not going to be described on this video. And the same is right here. We just uploaded the things, but we need to access this to make the drawing and use the data. Here is a shader. I created a shader class that's going to be used to simply load the shaders, the shader programs. On this tutorial, and on this video, we're going to use simple shaders. A vertex shader that's going to be describing the shader, the vertex position to the pipeline, and the fragment shader that are going to describe the pixel candidate to be drawn on the screen. The candidate will be explained in the near future. We have this class. This is not important right now because this is not so important, because we are going to describe the creation of the shader and the linking program to the GPU in the next section, in the next tutorial. And here we have the main loop of our application. First, we clear the screen with that setup color. This is needed because it's in the pipeline. We need to use a program, and after describe what pointers are going to be linked to that program. And here is a interesting thing. We have these channels on openGL that we can describe a channel to bind the data and access it on the shader. It's roughly a simple intro to this, but when we enable a 0 channel, we access this right on the shader. As it is a three coordinate described vector, this is going to be a vector. I'm going to explain this in next video. This is emphasized because I've started this trying to explain video showing the transformation, because I would want, but this is not a correctly form of information. And going back to this, we bind the buffer, and now we are going to describe the buffer itself on the GPU, and then we set the attribute that we want. The vertex buffer is formed by a 0 channel, then it is a 3 means that it's 3 coordinates to describe this vector. GL float in here describes the type of each individual element, and the element is here and it's a float. False. This is the parameter that is a normalized thing. Always described as normalized, but we can say that's not. Here we have the stride that is more like a jump into the data, because if you want to describe a 2 point and then say that, hey, the third element is going to be another thing, so we describe this and then the pipeline will ignore this. And the last parameter is the description of the jump. If in the same way we are going to jump this parameter if you describe it as 2. There's going to be 0, there's going to be 1, then the 2, and then he just jumps to this, but it's not necessary right now. And then we after describing the vertex 3 pointer, that is the pointer to the memory location of the GPU, then we bind the element buffer to describe the linking of the triangle. And then we call the draw. Draw function has a lot of options to this, but in this simple test we're going to use the triangle itself. And this is the size of the elements. The size of the elements is the size of the elements itself. That is 1, 2, 3. That's right. And this, the third parameter, is the type of the element. And the last parameter is a jump, because if you want to describe it, to use some of the elements to describe another thing, that's where you are going to put it. And at the last and the not least, you need to disable all the channels there that are going to be used. And that's it. We are going to test. Don't worry about this, I'm going to explain. I need to go to the compiled version of the program. This is the testing project, and here we are. This is a -1. This is 0 because it's 0 on the middle, and 1 because it's an upper, and because it's on down right is 1 for x, -1 for y-axis, and for all of the description is 0. If you like the video, please hit like, share on social media, and thanks for watching. The current explanation going to be disposed I hope one day. Thanks.